In this video, we're looking at Exam 1, Section 2, number 2D. And number 2D says, if f of x equals x squared plus x, use the definition. Use the definition of the derivative to find the derivative of f evaluated at 2. Okay. Well, first of all, let me show you what most of you did. Most of you said, okay, f of x equals x squared plus x, and I know some nice derivative rules, so this means that the derivative of f of x is going to be 2x plus 1, and that means the derivative of f at 2 will be 2 times 2 plus 1, so that's equal to 5. Right? Well, yes, of course, this is what the answer should be, and if you want to do this to get an answer so that you know whether you have done what this is actually asking us for, then good for you. So yes, this is the derivative of f evaluated at 2. The only problem is it's not what they're asking us for. So here is what it's asking us for. It wants us to use the definition of the derivative. If we want to get the points, we have to do what it asks. So let's use the definition of the derivative. I will remind you. Here is the definition of a derivative. The derivative of f at x is equal to the limit, as h approaches 0, of f of x plus h minus f of x all over h. We actually saw a problem that required us to recognize that definition earlier in this exam, and here it is showing up again. So let's make sure that we recognize this once and for all. Let's recognize this limit whenever we see it. So we're going to use the definition of this derivative to, we're going to apply this definition to the function that they gave us. All right, let's apply it to the function they gave us. So let's see here. The derivative of f of x equals the limit, as h approaches 0, of what? For this function. See, this function is, what this function does is whatever you give to it, you square it, and then you add it. Alright, so let's see here. I want to find f of x plus h. So this is the quantity x plus h squared plus the quantity x plus h. Do you see where this is coming from? I want to help you to see where this is coming from. Some of us need to practice composing functions. You see, this is, look, this is f of x equals x squared plus x. And here it is here, too. This is something squared plus something. It's coming from right there. So I'm going to go back to the blue. That's just this is just what f of x plus h is. It's right there. But now we have to, you see, we have to subtract f of x. So minus, and what is f of x? Oh, f of x is x squared plus h. Notice how I'm using these brackets because I'm going to be subtracting a quantity, x squared plus x. All of this is over h. Now we're going to expand the top and simplify. So this is equal to, the limit is h goes to 0. I'm expanding the top. I hope you see that x plus h times x plus h, that'll give us x squared plus 2xh plus h squared. Okay, this is just the quantity x plus h squared plus another x plus h. This subtraction sign needs to be distributed, so it's minus x squared and minus x. All of this is over h. Well, this is very nice, because now there are some things on top that are going to cancel out. You see, this x squared and this x squared cancel. And let's see, this positive x and this negative x cancel. That leaves us with, see if we can change the ink again. That leaves us with the limit as h goes to 0 of 2xh plus h squared plus h. All of this is over h. But look what we can do on top. This is all the limit as h goes to 0. In the numerator, every term has an h in it, so we can factor out an h. So it's h times the quantity 2x plus h plus 1. All of this is over h. Now we can cancel out those h's, and let's see what we're left with. So we have, this is the limit as h goes to 0 of 2x plus h plus 1. Now, in the beginning, if we would have substituted in, way back here in the beginning, if we had substituted in a 0 wherever we see an h, we would have had all kinds of problems. They would have become undefined. But that is no longer the case. After all of this beautiful work, we can now substitute in a 0. So this is equal to 2x plus 0 plus 1, which is, of course, 2x plus 1. So this is what the derivative of f of x is equal to. And we can use that to answer the question. The question asked us to find what is the derivative of f evaluated at 2. So that'll be 2 times 2 plus 1. Of course, that is equal to 5, which is what we were expecting it to be.